In fact, they happen every day. They happen every hour. They happen every minute. They happen every second, and they happen every microsecond. I can tell that you are fascinated about the space just like me. How do I know? Because you are watching this video, of course. And the rare view of a solar eclipse is no doubt a stunning beauty to watch, especially when it is a total solar eclipse. And there is one coming up at the time of recording this video on April 8th, and millions of people are rushing to watch this because the next opportunity to witness such a beauty from the United States will not come until 2044. But why are these total eclipses so rare? Wait a second, are they really rare? What if I tell you that they are not rare at all? Let's talk all about solar eclipses today. Hopefully, I will change your perception about this topic by the end of this video. I will try to peel one layer of this onion at a time, so please watch carefully to the end. First, what is a solar eclipse? A solar eclipse is where the moon is blocking the sun, which means you won't be able to see the sun because the moon is in between you and the sun. Plain and simple. This definition is important, so please make a note of it. We will come back to this shortly. If you want to understand how it works, do this small experiment for me. Place two balls of the same size on a straight line. Close one of your eyes. Look at the first ball from the eye that is open. Along the same straight line you place the two balls on. How many balls do you see? Just one, because the second ball is blocked by the first ball. The first ball in this case is the moon, and the second ball in this case is the sun, and that is a total solar eclipse for you. Very simple. I'm sure you already know this, but it's important for me to peel this first onion or first layer of this onion to get to the next. Second, why some parts witness less and some parts witness more of this eclipse? People, after all, rush to parts to maximize their ability to enjoy this rare phenomenon, isn't it? The answer is pretty straightforward. If you move your line of sight away from the straight line where the balls are lined up, you will start seeing the second ball slowly but surely. And you will reach a point where you will barely notice any obstruction. And that's probably an easy way to understand how total and partial eclipses work. The other way to do this is to move the ball itself right, left, up, or down. The point is, the amount and intensity of the eclipse depends upon where you are located relative to the two balls, the moon and the sun. It's all simple thus far, right? Now you may ask, we took two balls of the same size in this experiment, but the moon and sun are not of the same size. In fact, the moon is almost 400 times smaller than the sun. How does it manage to block such a large sun? That's because the moon is also around 400 times closer to us than the sun, making the relative sizes of them roughly the same from where we see it. Next, and the most crucial layer of this onion, how often do solar eclipses happen? After all, we are saying that this is extremely rare, with the next one not coming to the United States until 2044. Is it really that rare? What if I tell you that solar eclipses are not rare at all? In fact, they happen every day. They happen every hour. They happen every minute. They happen every second, and they happen every microsecond. True, but confused? Let me explain. You can always draw a straight line between the moon, which is one ball, and the sun, which is another ball. And if you look at the sun from that straight line, taking our balls experiment analogy, you will witness a solar eclipse. The issue, though, is you need to travel far, very far, to witness that into the void of space and stand behind the moon, or maybe I should say float behind the moon at a distance from which the size of the sun and the size of the moon look the same. And of course, one probable exception to that is during a lunar eclipse where the Earth is coming in between, but from that vantage point of where you are, you will not see the sun anyways, and you will probably not notice the Earth coming in between. So you can actually witness a solar eclipse right now. However, You don't need to go all the way to the space to witness solar eclipses. Right here on Earth, solar eclipses are more common than you think. Remember, Moon takes only 28 days to go around the Earth, and technically, there is a possibility of an eclipse happening every 28 days. But because the orbit of the Moon is tilted relative to Earth, we see a solar eclipse less often than that. But here is the fact. Moon comes in between the Earth and the Sun 2 to 5 times a year, at least partially, with a total solar eclipse occurring around every 18 months or so. So, partial solar eclipses occur at least 2 times a year, and total eclipses every 18 months or so. Technically, you should be able to witness a solar eclipse at least that often without having to go to space, isn't it? Then why wait until 2044? That's because you may not be in the line of sight of that eclipse, especially given you are moving at 67,000 miles per hour. But some part of the Earth will witness each of these eclipses, whether they are partial or total. Again, some part of the Earth will. If you are willing to travel to that part of the world, you can absolutely witness it. However, remember, our planet is covered with over 70% of water, which means you may have to travel very far, even on Earth, sometimes to the middle of the ocean. By the way, here you can see the list of eclipses from NASA that you can witness from the Earth in the next few years. Again, the location is there. You have to go to that location to be able to see it. Check it out. And please note that I'm choosing my words very carefully here. You can witness one anytime, as we discussed, if you are willing to travel far into the space. You can witness them more often if you are willing to travel to middle of nowhere on the Earth. But if you want to witness it from the land, you gotta wait. You gotta wait more if you want that to be total, and even more if you want the total eclipse to quote-unquote come to your neighborhood. To summarize, solar eclipses are not rare. Our ability to witness them are rare. Hopefully, I brought a different perspective to solar eclipses today and you enjoyed this video. Don't forget to wear protective glasses to see that gorgeous view. But before I let you go, do you know why you need to wear protective glasses? Because our eyes are not built to see direct sunlight, and it could burn our retina, which will not built to rehear. To know the effect, take a magnifying glass and focus on a paper. What would happen? The paper would eventually burn. Direct sunlight will have the same effect on your retina, just much faster. Have a safe solar eclipse viewing experience whenever you view it and wherever you view it from. See you next time.